Good morning friends. Today we are going to solve some problem of projection of line. Okay, so before starting the lecture, let's quickly revise what we learned in last lecture. In last lecture we learned about the different cases from which we understand the different condition of the line. Okay, from which we draw the front view and top view for the given line. Okay, so the conclusion of the last lecture is, okay, we get the true length of the line on the plane which is parallel to the line. Okay, for example, line is parallel to HP, then we get its true length on horizontal plane. If the line is parallel to vertical plane, then we get the true length on vertical plane. We get the point on the plane which is perpendicular to the line is perpendicular to HP, then we get the single point for the line on the horizontal plane. Okay, so we get the point for the line on the plane which is perpendicular to the line. Okay, and second thing, if the line makes an angle with HP theta, okay, then we represent on vertical plane because we seen the angle from the front. Okay, and we represent the front view on vertical plane. Okay, similarly, if the line is make an angle with vertical plane, okay, then we represent this angle on horizontal plane. Okay, because we seen this angle from the top view. Okay, let's start with this problem. Okay, a line AB 70 mm long. Okay, so true length of the line is equal to 70 mm. Okay, is inclined at an angle of 45 to the HP, so theta is equal to 45 degree and 40 degree to the VP. Okay, so phi is equal to 40 degree. Okay, its end point A is on HP, so point A is on HP and 25 mm in front of VP. Okay, 25 mm in front of VP. Okay, so here we have phi data. So solving this problem, first we require to find the four locus, means locus of A dash, locus of B dash, locus of A and locus of B. Okay, and after that from true length I draw the projection, and from front view length and top view length I draw the arc. Okay, here front view length is also called the elevation length and top view length is also called the plan length. Okay, so no need to confuse that here. Okay, so front view length is also called the elevation length and top view length is also called the plant length. Okay, let's solve this problem. Okay, first I mark the point A. Okay, for point A, condition given is point A is on HP, so I get the point A dash at here. Okay, so it's the front view of point A and 25 mm in VP. Okay, this is my reference line. Okay, so from here I take the 25 mm distance and mark the point A. This distance is 25 mm. Okay, this point A. Now we require to find the four locus. Okay, from four locus I get my first locus at here. This is the locus of A dash. Okay, and second locus this one. This is the locus of A. Okay, now the theta is equal to 45 degree, means lines make an angle 45 with the horizontal plane. Okay, this one is my horizontal plane and this one is vertical plane. Okay, line makes an angle with HP, but we represent it on vertical plane because it's seen from the front. Okay, so here I take the angle is equal to theta is equal to 45 degree and length is equal to 70 mm. Okay, I draw one line from the A dash. So here I get my point B1 dash. Okay, this is equal to true length. Okay, now here angle phi is equal to 40 degree. Okay, line makes an angle 40 degree with the vertical plane. Okay, so we represent it on HP. Okay, so from point A I take the angle phi is equal to 40 degree and length is equal to true length 70 mm. I draw one line at here. Okay, so at here I get my point B1. Okay, this length is equal to true length is equal to 70 mm. Similarly here 70 mm. Okay, now so here I get my third locus. This line is locus of B dash. Here we have point B1 dash and B dash on the same horizontal line. Okay, means its distance is same from the reference line. Okay, as we seen in earlier problem here, that the point B dash and B1 on same horizontal line. Okay, so here from B1 dash I draw one horizontal line which is my locus of B dash, so I get B dash point on this line. Similarly from here B2 I draw one horizontal line, so this is my locus of B. Okay, so I get the B point on this line. Okay, now I get my 4 locus. Now from true length I draw the projection line. Okay, so from here I draw the projection line which intersect the locus of A, because I get the projection of A dash at here A, so I take the projection of B1 dash up to this locus of A. Okay, so here I give the name B1. Okay, now similarly from here B2, okay, I take the projection line up to the locus of A dash, because I get the projection of A at here A dash, so I take the projection of B2 on this locus A dash. Okay, so here I get my point B2 dash. Okay, now I get the true length. Now from front view and top view length I draw the arc. Okay, at here this line A dash B2 is my front view length, and this line A B1 is my top view length. Okay, so from A dash point, now getting the B dash point, I have two conditions. Its length is equal to A dash B2 dash, and I get the point B dash on this line. Okay, so I take A dash as a center and A B2 as a radius. I draw one arc, okay, which intersected here. Okay, so here I get my final point B dash. Okay, so here A B dash is my final front view length. Similarly here, to getting the B point, I have two conditions. Its length is equal to A B1, and I get the B point on this line, locus of B. Okay, so I take A as a center and A B1 as a radius. I draw one arc at here, so I get my point B at here. Okay, so this AB line is my final top view line. Okay, angle made by front view length is called apparent angle alpha, and angle made by top view length is called apparent angle beta. Okay, here we see that the B and B dash point on the same vertical line. If I draw one vertical line from here, and it's on the same as A and A dash on same line. Similarly B and B dash on the same line. Okay, so if I once get this point B dash, then from B dash simple I draw one vertical line which intersect the locus of B, so I get B point. Okay, so we find in this way also. Okay, let's see another problem. Okay, in this problem given that the line PQ is 100 mm long. Okay, so its true length is given. I write down data here. True length is equal to 100 mm, and line is inclined at an angle of 40 degree to the HP. Okay, so theta is equal to 40 degree and 30 degree to the VP, so phi is equal to 30 degree, and one of its end point P is in HP as well as VP. So point is in HP and in VP, so we get this point on the reference line. Okay, so let's start this problem. Okay, to solving the problem, first we require to find the 4 locus. Okay, after finding 4 locus, from the true length we take the projection, and from front view length and top view length we draw the R. Okay, these points are important to solve the problem. Okay, now first I draw the reference line at here. Okay, now the condition for the point P. Condition for the point P is point is in HP as well as VP. So I mark point at here. Okay, and give the name P dash and P. Okay, because it's in HP as well as VP, so it's front view and top view at the same point on the reference line. Okay, now the angle theta given is theta is equal to 40 degree. Theta is equal to 40 degree means angle mixed with the HP. Okay, so we represent this angle on vertical plane. Okay, this is my vertical plane and this one is my horizontal plane. Okay, so I represent 40 on the vertical plane. So from here I measure the angle is equal to 40 theta, and length is equal to 100 mm. I draw one line at here. Okay, I here give the name Q1 dash. Okay, we want to find the 4 locus. From 4 locus, I have 2 locus at here. Okay, this line indicate the locus of P dash, and locus of P, and third locus I get at here. Okay, this is locus for Q dash. Okay, so I get Q dash point on this line. Okay, so from 3 locus we find. Another condition given is phi is equal to 30 degree. Okay, means the line makes an angle 30 degree with the vertical plane. So we represent this angle on horizontal plane. Okay, phi is equal to 30 degree. So from this point I measure the angle. Phi is equal to 30 degree and length is equal to 100 mm. I draw one line at here. Okay, so here end point I give the name Q2. Okay, so I get 4th locus at here. Okay, this is the locus of Q. Okay, because at the end I require to find the line P dash Q dash. This is my front view, okay, of the line, and PQ. Okay, this is my top view. Okay, so I find the P dash Q dash line and PQ line. Okay, so I get the Q point on this line and Q dash point on this line. Okay, now we find the 4 locus. Okay, so now from true length we draw the projection line. Okay, so now from Q1 dash point, okay, this is my true length, is equal to 100 mm. So from here I draw the projection. Okay, projection up to locus of P. Okay, so here I get my top view length. Okay, now this one is also my true length. So from this point I take the projection up to locus of P dash. Okay, this is the locus of P dash. So I get here point, I give the name Q2 dash, and here I give the name Q1. Okay, so this line up to this is my front view length. Okay, front view length is equal to P Q2 dash and top view length is P dash Q1. Okay, so now I get the front view length and top view length. So from front view length and top view length I simply draw the arc. I get the point Q dash on this locus. Okay, now I take P as a center and P Q2 dash as a radius. I draw one arc which intersected here. Okay, which intersected here. So I get my final point Q dash at here. Okay, so this P dash Q dash is my final front view. Similarly here I get the point Q on this line. Okay, this locus. So I take the P as a center. I draw one arc at here which intersect the locus at here. Okay, so here I get my final point Q. So this PQ line is my final top view line. Okay, this is my final top view PQ and final front view P dash Q dash. Okay, here angle made by front view length, this angle is my inclination, apparent angle alpha, and this angle is my apparent angle beta. Okay, that we find in this question. Okay, so in this way I solve this problem. Okay, here one thing you seen that Q dash and Q is on same vertical line. So we know required to draw the arc from here. If I get the point Q dash, then I simply draw the vertical line which intersect the locus. Okay, so I easily get point Q.